I'm Teacher Laarni. Welcome to Mathematics Grade 10. Today, we are going to learn about permutation and combination. There are concepts that are needed for an easier and clearer on the study of permutation and combination. To count the different ways an activity or set of activities that can be done is through listing, a table, a diagram, or an illustration of the problem. Okay, let us have an example. To travel from Legazpi, Albay to Baguio City, you can take a train, a plane, or a bus from Legazpi to Manila. And from Manila to Baguio, you can take a bus or a plane. Now the question is, in how many different ways can you make a trip from Legazpi to Baguio City? Okay, let us have the illustration or the diagram. The starting point would be in Legazpi, and you could take through a bus, a plane, or a train going to Manila. And then from Manila to Baguio, you could take through a plane or a bus. And so from this, you could now count that there are 6 possible ways from Legazpi going to Baguio. Why is it that we have 6 possibilities going to Baguio from Legazpi? That we're going to tackle it to the next lesson, that is by listing. Okay, by listing, we shall have bus, plane, bus, train, plane. So if we count it all, there are 6 possible ways. Okay, the next way would be by table. So in the first column, we shall have the bus, the plane, and the train. And then if it is the bus, it would be bus, plane, bus, train, bus. If it is the plane, it would be bus, plane, train, plane. So if we count it all, we also have 6 possible ways as trips going to Baguio City coming from Legazpi City. Another way of counting technique is the tree diagram. So in the set 1, Legazpi to Manila, and set 2 possibilities would be from Manila to Baguio City. So from the start, we have the bus, the train, and the plane. Next, from Manila going to Baguio, it would be through the bus or a plane. Bus or a plane, bus and a plane. So, if we tally this all, it would be bus, plane, train, bus, train, plane, bus, plane. So, how many possibilities are there? There would always be 6 possible ways to make us trips from Legazpi to Baguio City. So in our previous examples, as the number of things to be arranged increases, it becomes more difficult and time-consuming to list and construct diagrams to show all the possibilities. A generalized method for finding the number of ways a set of choices can be arranged is by using the fundamental counting principle. This is a more efficient method for solving complicated counting problem. Okay, let's have the example on the travel problem. So we have done that there are choices to go to Manila from Legazpi. That is by plane, by train, or by bus. And two choices to Baguio City from Manila. That is by plane or by bus. So using now the fundamental counting principle, the first choice is 3 choices. And then we multiply it with the 2 choices. Thereof, we have 6 possible ways to go to Baguio City coming from Legazpi City. Okay, let's have another example. In how many ways can a student guess the answers to a 5-item true or false test? So, we are going to use the fundamental counting principle. And so, the first one would be, since that is a true or false, we have a 2 times 2, another times 2, another times 2, another times 2. Since we have a 5-item, so 1, 2, 3, 4, 5. So if we multiply now 2 times 2 times 2 times 2 times 2, you would have an answer of 32 ways. So we're done with the counting techniques. Our next topic is about factorial. Factorial. So, what is a factorial? So, we are going to answer the activity that is, in how many ways can you arrange different colored buttons in a row if you use 3 buttons? So, we could have the arrangement, if it's 3 buttons, it would be 3 times 2 times 1. So we would have an answer of 6 ways. Next, what about if it is the arrangement of the 4 buttons? So we shall have 4 times 3 times 2 times 1, and we have an answer of 24. Next, what about if it is 5 buttons? So it would be 5 times 4 times 3 times 2 times 1. And we will have an answer of 120. Next, what about the arrangement of the 6 buttons? It would be 6 times 5 times 4 times 3 times 2 times 1. And we will have an answer of 720 ways. Next, what if we will have the 7 buttons to be arranged? And it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And we shall have an arrangement of 5,040. Looking at the notation, there is a shorter way of writing these factors. Let us have 3 times 2 times 1. This could be written as the notation of 3 factorial. Moreover, if it is 4 times 3 times 2 times 1, of course we will have the notation of 4 factorial. Same through with 5. We shall have 5 factorial. For the 6 times 5 times 4 times 3 times 2 times 1, we'll have the shortcut that would be 6 factorial. And same through with the 7, we'll have the 7 factorial. So, this factorial is a notation whereby we could have it, writing it in a shorter way. Okay. How will be the following be simplified? Let's have an example. 1. How shall we simplify 2 factorial times 3 factorial times 4 factorial? Of course, what is 2 factorial? That is 2 times 1. 3 factorial will have 3 times 2 times 1. And of course, the 4 factorial would be 4 times 3 times 2 times 1. And the final answer, if you multiply them together, it would be 288. Okay. Another example. What if we have here 8 factorial divided by 7 factorial? So, of course, this would be 8 factorial, meaning 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. Looking at the given notation, we could have the shorter way. We could now cancel 7, 6 with the other one. So the final answer would only be simply 8. Okay. Understood? Okay. So we're done with the activities regarding factorial. So you have to remember that a factorial is a notation used to express the product of 1 and all the positive integers up to the integer n is n factorial. For any natural number, n factorial would be equal to n times n minus 1 factorial. So you have to remember the definition of this factorial. Our next topic is permutation. So how do we define permutation? Permutation is an arrangement of objects in a specified order. The number of ways for R out of n is n times n minus 1 times n minus 2 until R factors. To understand more about permutation, let us answer this activity. From the digits 1, 2, 3, 4, and 5, how many arrangements can be formed using 1 digit? If it is 2 digits, 3 digits, 4 digits, 5 digits. Okay, to answer that, if we are going to use 1 digit, the arrangement that we would have would be simply 5. Now, from 1, 2, 3, 4, 5 as the numbers to be used, if it is 2 digits, we shall have 5 times 4. And it will give us 20 arrangement. Next, for the 3 digits, it would be 5 times 4 times 3. And that will give us an answer of 60. What about if you use the 4 digits? Therefore, we will have 5 times 4 times 3 times 2. And we'll have an answer of 120. What about if we are going to use the 5 digits? Of course, we'll have 5 times 4 times 3 times 2 times 1, and the answer would be 120. Okay. Now, instead of the 2 digits, we could use the 2 factors. But we have to start it from 5. So, we shall have 5 times 4. Now, for the 3 digit, we use the 3 factors. And we have to start with 5. That is 5 times 4 times 3. So, with the 4 factors, we shall have to start with 5 again. So, we shall have the answer of 5 times 4 times 3 times 2, and so on. So, for the n digits, taking 5 at a time, the number of arrangement would be n times n minus 1 times n minus 2 times n minus 3 and n minus 4. Now, if we have the r factors, we have the notation as n times n minus 1 times n minus 2 times n minus 3 until it would be n minus r minus 1. And to simplify it further, we shall have n times n minus 1 times n minus 2 times n minus 3 until n minus r plus 1. Okay, let us solve this problem. How many 4-digit number can be formed from 1, 2, 3, 4, and 5 if the condition letter A is repetitions of digits are not allowed? And for letter B, repetitions of digits are allowed. So how shall we solve it? Okay, let's have letter A. What would be the solution for this? It is simply, since there are 5 digits that we have to use using 4, it would be 5 times 4 times 3 times 2 times 1. So we have 120. Okay? But that is for letter A. What about for letter B? What if repetitions of digits are allowed? So we shall have, the first choice would be 5. The second digit would also be 5. Same through with the third and the fourth. Or this would be 5 raised to the 4th power and the final answer would be 625. Okay, understood? Can we use the rule if we are allowed to repeat the digits? The answer is no. In this case, we have to study further on the kinds of special permutation. First, we have the permutation with identical object. Second, repeated use of the same object. Third, the circular permutation. The number of permutations P of n objects taken n at a time with R objects alike, S of another kind alike, and T of another kind alike is P equals n factorial divided by R factorial, S factorial, T factorial. Example, find the number of permutation of the letters in Lala. There are 5 letters which include 2 A's and 3 L's. Thus, P is equal to 5 factorial divided by 3 factorial, 2 factorial equals 10. The repeated use of the same object. The number of arrangement of n objects taken R at a time with the repetition is n raised to the R power. Example, how many 5-letter ordered codes can be formed with letters J, E, R, and Y if we allow repeated use of the same letter? We can select the first letter in 4 ways, the second in 4 ways, and so on. Thus, there are 4 raised to the 5th, or there are 1024 orderings. Circular permutation. It is the number of circular permutation of n object is n factorial over n, or n minus 1 factorial. Example, find the number of circular permutation of 5 people. 5 minus 1 factorial is equal to 4 factorial equals 24. Okay, we shall now study combination. So with this problem, in a birthday party, there are 6 guests. How many handshakes are there if each guest shake hands all the other ones? To solve this problem is simply by listing. Okay, let's have guest A. Guest A shake hands with B, C, D, E, and F. Therefore, we'll have 5 ways. Next, for guest B, we'll have handshake with C, D, E, and F. Not A anymore, because A with B is the same as B with A. Remember that? So we only have 4 ways. Next, for guest C, the handshake would be with D, E, and F, and we will have 3 ways. Next, for guest D, it would be with E and F, and that would be 2 ways. And for guest E, it would be only 1. If we're going now to add, for guest A till guest E, it would have 5 plus 4 plus 3 plus 2 plus 1. So the total possible handshake is 15. Okay, is it clear? You might be wondering about guest F handshake. It would be 0. Why? Because guest F handshakes are already counted in guest A, B, C, D, and E. Using now the formula, C is equal to n factorial over R factorial times n minus R factorial, we'll have now the given. N is 6 since there are 6 guests. R is equal to 2. That is, two guests will have to have the handshake. So, substituting it from the formula, 6 factorial divided by 2 factorial times 6 minus 2 factorial. So 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1. 2 factorial, that would be 2 times 1. 6 minus 2 is 4. So we'll have 4 factorial, 4 times 3 times 2 times 1. So we could now have the cancellation. 4 and 4, 3 and 3 cancel, 2 and 2 cancel, 1 and 1 cancel. Now, 6 by 2, we have there 3. And that's it. 3 times 5 is 15 over 1 or 15. So our answer is 15 ways. This is the same through by listing that we have done a while back. Okay, using the formula C n r is equal to n factorial all over r factorial times n minus r factorial. Now, problem number 1 would have the solution. So, what would be our n? There are n is equal to 9 marbles. And your r, since it is stated there, if I draw 4 marbles, so that's your r, is equal to 4. So, substituting it from our formula, we shall now have 9 factorial divided by 4 factorial times 9 minus 4 factorial. To simplify that, 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 factorial would be 4 times 3 times 2 times 1. And then this would give us 9 minus 4 is 5 factorial. So, we now have 5 times 4 times 3 times 2 times 1. Okay. Observe the numerator and the denominator. So, 5 and 5 cancels out. 4 and 4. 3 divided by 3. 2 divided by 2. 1 divided by 1. Now, what about this? We could cancel 9 and 3. This would be 1. This would be 3. 8 divided by 4. Of course, this would be 1. This is 2. 7. None. So, for 6, 6 divided by 2. This is 1. 3. So, the final answer would be 3 times 2 times 7 times 3. And it is equal to 126 sets. Okay. Thank you for watching.